Okay, we're having fun. Got it. He did all the red stuff he did, right? So, got the factors. Got where it crosses, right? The roots, as they say, where it crosses the x-axis. Got a nice drawing, or a nice manipulative representation. And, can I get in there? And then he's putting it in his book, too, right? Writing it all out and making sense of it for himself. Okay. Now we can make a quick, now let's get more and make a quick sketch. So now I know that when x is -4, y is 0, and when x is, we'll call that 2. And see, now we have a little more space. And we'll call that 4. Preach. Preach. Let's use this. Well, I don't know. So, probably like that. Okay. Alright, just, right? Okay, so now we know those 2 points. Now, let's talk about the axis of symmetry. Where would it be, like, just halfway between these 2 points? If this is, I can even use this. If this is -4, and this is -2, right? Then we always do x, y, right? So x first. Okay, so those are actually those points, just like playing Battleship, right? And that should be a negative there. Okay. Now, we've got that much information. Where is that? In other words, where is the axis of symmetry? Where would it be that we go, well, halfway between these 2 points? Right? Because a parabola is a symmetrical figure, right? Half of it's on this side, half of it's on that side. Okay, so we find the axis of symmetry by just going halfway between these 2. So what's halfway between 2 and 4? On a number 2. Line.
I mean,
between 2 and 4, what it should be?
3.
There you go, right? Pretty simple, except -3, right?
Yeah.
But you're exactly right. Okay, so we don't have to remember a formula, because what they're going to do is they're going to try and give you a formula. You take -b over 2a. Well, -b over 2a would be indeed 3. Right? But you can just see it. Okay, so now we know the axis of symmetry. Now I don't know how far it goes down, but what I have to do is, and now I have to go in and put -3 in and see what happens at -3.
So you put -3 there.
Yep, and I get what? What's -3 plus 4?
It'd be 1.
And, okay, so I know 1. And what's -3 plus 2?
It'd be -1.
Yep, so -1 times -1 is, or excuse me, what I have? I have 1 times -1.
Would be 0.
1 times 1.
Be 1.
And negative, right?
Oh, so it'd be negative. Oh, yeah.
Yeah. So, that's me trying to take the pen off, the cap of the pen off. Alright, so it go down to like -1, which would be like about there. Alright, so now look at that. Now we know where it goes down and stops. Right, what is it? Why do we do that? Well, because I know at that point, when I put it in, I find the x value, and then I find the y value. Right? What I just did when I put the -3 in is I found the y value. So, okay, now I know what that point is. Okay, so look at that. Oh, wait. Now we need just a little bit more information, and I'm going to do this. Watch. I'm going to take x. I'm going to use a little bit of algebra. And x times what is x squared? Well, just x times x, right?
Mm-hmm.
X times what is 6x?
6.
Right? Simple.
Yeah.
He's always thinking that I'm going to try and trick him with a hard question. And I'm not. It's just keep it simple. Okay, so now I know that much. Oops, and then I have to add 8. Aren't these two exactly the same?
Yeah.
In fact, I can say this and this are equal, and this are, all 3 of those are equal. Right? Same, crucially important concept in mathematics.
Huh.
Right? Okay, the concept of same. Okay, so now I can find out more information and figure out when it's 0. Well, what has to make this whole thing, well, let's find out what happens when x is 0. Okay, why do I want to do that? Because when I find out when x is 0, what happens at y? So, and I know that once I make x 0, this is 0, so then I just have plus 8, right?
Yeah.
Okay, so when x is 0, plus 8. Right? That's kind of like that y-intercept. Okay. This pen is no longer cooperating, so let's try this one. See if that one works. Oh, that one worked great. Okay, see? Now, I also know that I could take and make this one 0. How would I make this 0? What, -6, right?
Yeah.
So -6, and this whole thing is 0, I'd be at +8. So over here at -6, I'm drawing it, and you should draw it in your book. Boom. So now I have 5 points. And those 5 points are important points for me to be able to draw this thing. So now I can go, okay, I know that my parabola goes through this point, through that one point, and back there, and I'm actually glad my pen didn't work that well, because I'm going to find it. Let's go with blue. Okay, so it goes through this point, it goes through that point. And so you might have on your test, you might have a question like, which one of these points is not contained in this function? Right?
Right.
And I could have one that's like, you know, here or something. And they're always going to give you one that's crazy off. That there's no way. That should be obvious, right? And they'll give you 4 that are on, or 3 that are on, and 1 that isn't. Okay, so now I have all these points. I know these 2, I know these 2, I can label those, right? And I can label, and wait a minute, that drawing, your drawing is upside down. This drawing is for you, brother. I'm drawing upside down for you. Right? X is, the Y positive value is this way, right? And the X positive value is that way.
Okay, I get it.
Yeah.
So that's up there.
Yep.
It's coming down this way.
Okay, so draw what you see. So it should be over there, is going to be in the negative quadrant, right? He's putting it in his notebook. Okay, so now we can label all these points. I know this point right there is X is 0, Y is 8. See, look, we got all these points. And then I know over here I got -6 and 8, those 2 points. And over there I already labeled. And then over there, this point right here, the apex, is our vertex, excuse me. Looks like an apex because I have it upside down from where I'm sitting. Not for you though, because I'm over here. Right? Anyway, so the vertex, and this is actually vertex form, is 3. Let's see. So I know that when I put -3 in, I get 1. So I'm going to put an arrow because it's going to be too yucky. And I'm going to say that when X is -3, Y is -1. So there you go. 1, 2, 3, 4, 5 points, and you can. That's more than enough information to draw with.
Okay.
Okay. And it's
that last one right there? That's
-3, 1. -3, -1. Okay, and you introduce, like, to normal students and to little 5-year-old kids and 6- and 7-year-old kids, you'd introduce this in stages over hours, not all in one class, right? But like I said, we got work to do. Okay, so see how it works?
Yeah.
Okay, so now graphing these things, not a problem, right? Now you can see that later on, or right now we've stayed positive, and we're going to, in the next class, we'll talk about what happens when it's negative, that we can start moving this thing around depending on what this function looks like. Right?
Right.
Okay, so we can start taking a look, and if we do enough of these, we should get comfortable and figure out, well, how could we get it to be here and pointing up? Or how could we get it to point the other way, downwards? Or how could we get it to point sideways? Or how could we get it to do all this other stuff? But right now, we're just getting used to finding the roots, finding a couple extra points, figuring out where the vertex is, axis of symmetry, pow. Okay?
Okay.
So let's do another one. Let's take you take the red pen, and let's do, and we'll change all this stuff up. X squared, yeah, everybody that's red gets erased. That makes it easy. X squared. Ooh, let's do an easy one, a fun one. How about x squared, 8x, and 16? This is a square function. Over here, 8x. We'll figure that out in a second. Well, actually, you know what? You're right. You're right. It would be 8.
All the way,
Yeah, no, not all of them. We have to figure out what the factors are, but that would be 16. Yep. Oh, these kids smart like that. Okay. See?
So
See what happens when you change the... That right there is a huge clue. Should be a big clue for teachers. Because if stuff changes, but you change the colors of the pens and suddenly, oh. So we should... let's use blue for that. Or we could use orange. Okay, I want 16 in there. You're going to build 16 with 6s?
Oh wait, 16.
And we need 8x. Have you got 8x? Okay, so you just figured out 8x and 12, right?
Yeah.
That would be 12. I don't want 12. I want 16.
Yeah,
So that's good. No, see, you're not wrong. You just get more information. I want fit 16 in there, so you're going to have to move some of those guys.
Oh, so we want to...
Oh, okay. Well, we do that. We're going to actually fit less in there.
Fit less?
Right? We'll put it over there for a second.
Yeah, okay.
Right? We would only fit 7. So, oh, boom, he moves both of them at the same time. Now how many's going to fit in there?
We're going 4, 8, 16.
Yeah, there you go. See, in that, you're good because you can multiply. My 5-year-old, actually my 5-year-old now can multiply at least that much. He can do 16 easily. But kids that can't multiply, that's a lot of counting right there, right?
Yeah.
They got to count to 16.
Okay.
Okay, looks good to me. Okay, and can we see what are the factors?
4 and 4.
Right, both times. It's going to be x plus 4 and x plus 4. So you can put it there. I'm going to show you a different way to write it also. Is you could just write it like this, right? X plus 4 squared.
Okay.
See that?
Yeah.
Okay. So now this, and that are equal. Okay, why write it twice? Okay, so now we're only going to have 1 over here, right? Instead of 2, it's only going to be what?
4.
Yep. -4, that's it. Always remembering that, right? So now I want you, let's turn off the camera and erase all that, and we're going to draw we'll come back and have him do it. But that would be your work at home, is to erase all this and come back and tell me what does that graph look like give me the 5 points. Okie dokie? Alrighty.